Hello and good day. Welcome to my math class in Statistics and Probability. I am Teacher Burns. So we are going to have consolidated lessons using Module 1 to Module 3, which is about random variable, probability distribution, variance, and standard deviation. After this video, you should be able to distinguish random variables in random sampling, identify probability distribution, and differentiate statistic from parameter. Now, what are random variables? Variables in mathematics are shown in the following. X plus 5 is equal to 8, or 12 minus y is equal to 7, where in the first equation, x is the variable and the value for x is 3 because 3 will satisfy the equation x plus 5 equals 8. In the other equation, our variable is y and the value of y is 5 because 5 satisfies the equation 12 minus y equals 7. But in statistics, random variables are quite different from mathematical variables. Let us have these examples. Number 1, number of defective cell phones produced in a manufacturing factory daily is an example of random variables. Another is the amount of paint needed to repaint a room. Another example is time needed to walk from home to school. The gender of students taking up BS Criminology are random variables. Lastly, you have height of applicants for Miss Universe pageant. Now, there are two varieties of random variables that are numerical in nature. So we shall be comparing discrete random variable and continuous random variable. When we speak of discrete random variable, this talks about number of rotten bananas in a bunch of bananas, number of honors students in a class, number of tiles needed to cover a floor. All of those mentioned are examples of discrete random variables. How about continuous random variable? We have the growth of tomato seedlings per week, time needed to finish an exam, or the weight of pigs after 3 months. These are examples of continuous random variables. So what's the difference between discrete random variable and continuous random variable? When we speak of discrete random variables, these are values that are achieved through counting, while continuous random variables are those that are achieved through measurement. Now let's go back to our example and classify which one is discrete and which one is continuous. Again, discrete are achieved through counting, while continuous are achieved through measurement. Number 1, number of defective cell phones produced in a manufacturing factory daily. Number 2, amount of paint needed to repaint a room. Number 3, time needed to walk from home to school. 4, the gender of students taking up BS Criminology. And lastly, height of applicants for Miss Universe pageant. So which one belongs to discrete and which one belongs to continuous? Number 1 is discrete random variable. Number 2 is also an example of discrete random variable. Number 3, which is time needed to walk from home to school, is an example of continuous random variable. The gender of students taking up BS Criminology can be identified through counting, so it is under discrete random variable. While the height of applicants from Miss Universe pageant are data that can be achieved by measurement, so this is an example of continuous random variable. I hope you have understood this part. Let's move on to probability distribution of discrete random variables. Why do we use random variables? The purpose of using random variables is so that we could measure observations and process data to make a conclusion about the population. Suppose you are to test 3 random eggplants from a harvest to see if there are worms in it. You want to find out the number of eggplants attacked by worms. We use W to represent if there is a worm attack in an eggplant and N if there is none. So we have this table of the data that we have gathered. The first column talks about the possible outcomes. The second column is recording the number of eggplants with worm attack, while the third column is the probability. So first is, we observe each of the eggplants, and if our observation tells us that there is no worm attack in each of the 3 eggplants, then our possible outcome will be N, N, N. This means that there is no worm attack. That is why under the second column, which records the number of worm attacked, we put 0. Then, for the probability, there is only one possible outcome, so we put 1 in the numerator. Later, I will tell you why the denominator is 8. So let's continue. Next is having only one worm attack. So this is W with worm attack, no worm attack, and no worm attack. So W, N, N. So we put in here W, N, N. But it could also be in the form N, W, N. So still there is only one worm attack. So we put that under the second column with one worm attack. So how many worm attacks? There's only one. But also, there's a possibility that the arrangement would be N, N, and then worm attack. Still, there is only one worm attack. So we put that together with this group having only one worm attack. So what are the possible outcomes with one worm attack in the 3 eggplants? So we have here 3 possible outcomes of having only one worm attack. So we put here one worm attack, we put here the 3 possible outcomes, and in our probability, there is 3 over 8 as the probability of worm attack. Why 3? Because there are 3 possible outcomes. Next, what if this is the observation? Among the 3, 2 of the eggplants are attacked by worms, and the other one has no worm attack. So we write that as W, W, N. We put that here in the next box. W, W, N. How many worm attacks? 2 worm attacks. But it could also be in the position W, N, W. Still, there are 2 worm attacks here. So it is placed together with the other observation that we have, having 2 worm attacks. Next is, it could also be N, W, W. So still, there are 2 possible worm attacks. We have N, W, W. How many worm attacks? 2. How many possible outcomes in here? 3. We have W, W, N, W, N, W, and N, W, W. So we put in the numerator 3 over 8. Lastly, there is a possibility or a probability that all of the 3 eggplants have worm attack. So in this case, we put W, W, W. How many worm attacks? 3 worm attacks. So therefore, we put 3 in here. But how many possible outcomes? There is only one, having W, W, W. Now, next question is, how did we get a denominator of 8? Let us go back to our possible outcomes. Count the number of possible outcomes. 1, 3, this makes it 4, plus 3, that is 7, plus 1, that is 8. So therefore, all the denominators of our probability is 8. And the numerator refers to the possible outcomes. You see, 3 and that is 1. Now, how do we know that our probability is correct? We will have to get the sum. If the sum of the probability is equal to 1, then our probability is correct or valid. Next is, upon knowing the probability, my question is, which one among these 3 probability table is valid? Is it A, B, or C? Let's try to find out. Remember, the sum of all probabilities in the distribution must always be equal to 1. The first one has a total of 20 over 20. Simplified is equal to 1. So therefore, this is a valid probability. Next, the sum is 11 over 10. Oh no! This is not a valid probability. The next table, C, is equal to 10 over 10, which is equal to 1. So therefore, this is a valid probability distribution. I hope this is understood.